All right, welcome back to the next lesson. We're still in unit 5 here. This will be our last unit for the year. And we just wrapped up the lesson 3, which deals with different ways to represent equations and the end result. And today we're going to look at lesson 4, which starts in on page 18. And we're still looking at these things, and we will be for the whole unit. So here on page 18 and 19 for today's lesson, let me share the camera with you here and we'll get going. Okay. So arranging instructions in order. So trying to figure out which thing goes where. So arrange these 4 instructions so that they lead to the final step in the record of each calculation. Okay, I think they want you to cut them out, but we're not going to. You may want to make sure that you're using a pencil. That way you can redo things. Okay, so we can work backwards here. It looks like the last thing they did here was add 7. Okay, which was right here. So we got that one out of the way. Let me just put a block there on that so that we don't see it. Okay, and then here it looks like they divided by 2 because they're doing it to the whole thing. So divide by 2, we got that one out of the way. Okay, and then before that, it looks like we'd have 3w minus 5. So subtract 5. Subtract 5. And then the last thing is multiply by 3. You would have got 3w by 3 there. Okay. So it's easy to see this story and work our way backwards. Okay, the last step we did here was divide by 2. So cover that one up. And if you don't divide by 2, you get 3b plus 7 minus 5. So minus 5. So subtract 5. I get rid of that. I get 3b plus 7. So it looks like we multiplied by 3. Cover that up. And then you have b plus 7. So you add 7 there. Okay. So we can do, different things to get different answers here. And notice how different they are. Okay. The location of all these numbers and the signs and the parentheses, all of that is very, very meaningful. Okay. So on number 2, we're doing the same kind of thing. Arrange these 4 new instructions so that they lead to the final step. So let's see if we can start at the top this time and work our way down. So in here at the end, the first thing you would do is add 12. So n plus 12. Is there an add 12? Add 12 right there. So add 12. Okay, and then after you added the 12, you divide by 4. So n plus 12 divided by 4. So divide by 4, which is right there. And then they subtracted 10. So you have n plus 12 over 4 minus 10. Right there's a subtract 10. And then they multiply by 2. Okay, which was right there. Okay, we'll do this next one the same way. So we started with C. The first thing we did is divide by 4. So divide by 4. And then they subtracted 10. So subtract 10. So it's C over 4 minus 10. And they took that whole thing times 2. So multiply by 2. So you get 2 parentheses C over 4 minus 10. And then the last thing is add 12. Okay. So these things can get very large very quick if you're keeping it all together. Malika thought of the number 12 and went through the steps in the two tricks in problem 2. So she went through both of these. What number did she end up with after each trick? Okay, so problem 2A, she thought of the number 12 first. Okay, so if I take 12 and I add 12 to that, get 24. If I divide that by 4, I would get 6, because 6 times 4 is 24. Subtract 10, so I'm going to get -4. Multiply by 2, I'd get -8. So that's a -8 for that one. Okay, and for problem 2B, again, she thought of 12 at first. Divide by 4. 12 divided by 4 is 3. Subtract 10. Well, -3 minus 10 is -7. Multiply by 2. 2 times -7 is -14. Add 12, you're going to get -2. Okay, so we got a couple different answers there. These problems use the same steps in a different order. Does it change the final result? Yes. Order matters. Okay. The order in which you do things really matters. Okay. That's why when solving an equation, okay, you have to do things in a right order. That's why we have order of operations. Okay, number 5 through 12, they're all kind of the same thing here. It says match each expression with a set of instructions. Okay, so here it looks like we took a number times 4. Think of a number, multiply by 4. Then we subtracted 18. Okay, here's one that says subtract 18. So it looks like this one goes with that one. We took a number times 4, then we divided by 2, and then we subtracted 18. So this one goes here. We took a number minus 18, subtract 18, then we multiply by 4, then we divide it. So this one goes here. We took 18 minus some number. Okay, that one isn't listed here. Oh, I messed up. Okay. Subtract it from 18. I read that backwards, actually. So this, we subtracted 18 from it. So this actually goes down here. And this one goes up here. That's my fault. I was wrong. Okay, those two need to switch. Be careful reading it. That's just proof that you got to slow down and be careful. Don't make the same mistake I did. Okay, so we're going to think of a number. It looks like A in this case. Multiply by 5. So I'm looking for 5A. So these two have it. Subtract 10, then divide by 6. So this one subtracts 10, then divides by 6. So this one's coming down here. Think of a number, subtract it from 10. So both of these subtract it from 10. Divide by 6, then multiply by 5. Okay, this one goes here. Think of a number, subtract it from 10. Multiply by 5, then divide by, yep, that's what this one says. So this one is none of those. Okay, so read through that story read through this story and see which one matches up. Subtract x versus subtract from x. Okay, this is exactly what I just messed up on. Okay, whenever you're uncertain about an operation or a process, try it with a few simple numbers and keep track of your reasoning. For 10 minus b, you might think, suppose b is 2. Am I thinking of my 2 and then subtracting? Or am I thinking of my 2 and then subtracting 2 from 10? Okay, so just slow down and see which one you're doing first. The order of subtraction really matters. For each algebraic expression, write the instructions step by step in the correct order. So they give us this part. We need to write this. Okay. All right. So here we've got think of a number. So we got think of a number, B, subtract it from 10, divide by 2, and then we subtract 19. Okay. Notice the word from is in here, but not in this one. Okay, here we have think of a number, subtract 9, multiply by 6, okay, I know to do that first because this division goes over the whole thing. So that division has to be last. Divide by 3. All right, here's kind of tricky. Okay, so think of a number. And we took the number times 10. And then we subtract that from 3. So because it's second, so we got to take it away from 3 and multiply by 5. So just be careful on those steps. What are the only two numbers that circle could be if circle times circle equals circle? Okay, there's two numbers, and you could just start trying out numbers. Okay, positive, negative, it doesn't matter here. So this says 2c equals c. There's only two numbers that can do that. Okay, if you start with a small number, let's say 2. Well, 2 times 2 is 4. That doesn't equal 2. So maybe go smaller. Oop, I did that wrong. It's circle times circle. So that would be 2 times 2 equals 2. 2 times 2 is 4. That's not it. What about go smaller? Go 1 times 1. Does that equal 1? Yes. So 1 works. Or if I go smaller, 0 times 0 equals 0. 0 times 0 does equal 0. So 1 or 0 is the only, and I would represent this by saying circle squared equals circle. What is the only number that a heart could be if heart plus heart equals heart? So again, we can just try numbers. 2 plus 2 equals 2. No, because 2 plus 2 is 4. What about 1 plus 1 equals 1? No, because 1 plus 1 is 2. What about 0 plus 0 equals 0? Well, 0 plus 0 is 0. So that's the only number that would work. Okay, which is why we exclude 0 in a lot of things because it works for almost everything. Here we would represent this by 2h equals h. All right, that is all for this lesson. The next lesson will take us on the back side here, but you could, if you wanted, start the additional practice here on page 21. If you have any questions, feel free to reach out. And as always, I'll see you in the next lesson.